Hello, my name is Jake, and I'm going to be going over the ultrasonic sensor. This sensor uses ultrasonic waves to detect the distance between the robot and the wall. It sends out ultrasonic waves and then times how long it takes for them to return to the robot. And then using that time, it determines how far the object the waves must have bounced off of is from the sensor. So now I'm just going to do a simple demo where the robot will drive until it is 6 centimeters away from the wall, and then it will drive back to its original distance. And now I will show you the code for that demo. Hello, my name is Jake, and I'm going to be going over the code I used to perform that demo you just saw. Now, first we're going to start from the top. We have these lines here, which are importing modules into the program. Now, the exact details of how these lines work is not too important. What matters is that if there's something that you want to use, you have to make sure that it is being imported up here. But luckily, the Spike software automatically generates these lines for you, so it's not that big a deal. Next, we have to set up and initialize our motors and sensor. So for each motor, we have to create a motor object and assign it to a variable. So here we have our variable called left for the left motor, which we are saying is plugged into port C, and right for our right motor, which is plugged into port D. Now, these names here are not that important. They could technically be named anything, but calling them left and right is just useful for readability. But you do have to make sure that this character here, this C, matches the same port that the motor is plugged into on the robot, or else this isn't going to work. The same applies for the distance sensor, which I am calling ultrasonic because it is also an ultrasonic sensor. Just we set up with this distance sensor object, and we are saying that it's plugged into port F. Now, to do what we did in the demo, we had the robot start at a certain distance, we had it drive until it was 6 centimeters away from the wall, and it drove back to the original distance it was set at. So we have to figure out what our starting distance from the wall is. So here we use ultrasonic to refer to the distance sensor, and we use get distance centimeters to understand how many centimeters we are away from the wall. Now, this isn't the only way you can interact with the ultrasonic, with the distance sensor. Over here in knowledge base, you can go down to where it says distance sensor, click the drop down, and it will show you how to import it and how to initialize it, as well as a bunch of different functions you can call to get to interact with the ultrasonic. So if I wanted, I could do everything in inches, but I prefer centimeters, so that's what I will be using. And then here, we also want to initialize our current distance because we always want to be checking our current distance to the wall, but we also don't want to be confusing that for whatever our initial distance was. So since we started at this initial distance, we want to set our current distance at the beginning to be the same as our initial distance. Now, we get to the meat of the program, actually moving towards and away from the wall. So we set up a while loop because we want to make sure that this code here executes while we are greater than 6 centimeters away from the wall. So we have our current distance variable, which we will be updating every loop, and we want to make sure that that is greater than 6 to ensure that we have not crossed that 6 centimeter threshold. Then what we have here, this doesn't actually contribute to moving the robot. This is what we call a debugging statement. It helps in case the robot isn't doing what we expect it to, and we want to get some output from the program to help us figure out what's going wrong. So here we have, we give it our argument, which will tell it what to display. This here is a string, so this is just characters and words. It doesn't think of it as code in particular. It's an argument that just consists of words. And we say current dist for current distance, and then we have these two braces here, which indicates we're going to we're going to replace that with something else. And to say what other thing we're going to replace that with, we use dot to say we're going to perform an operation on this string, and then the format function, which is going to look for these two braces and replace it with whatever is within these, whatever is right there. Now, this is the same function that we used up here with our ultrasonic sensor, or our distance sensor, to get the distance to the wall. So we're going to figure out how far our distance is to the wall, and we are going to print that out all in front of current dist. So you can see down here from when we ran it, all of these being printed out to the terminal. This is how you access the console where you'll see all of your output. And then we actually have to update our current distance variable, because if we don't, then we won't be properly checking our distance. It doesn't automatically update. So here we have current distance is equal to, we get our distance again. And then we have to actually change our motors. So now one thing that's important here to note is that if you weren't necessarily using sensors to move the robot, a lot of the time you're going to move your motors like a certain distance, like a certain number of rotations or a certain number of degrees. But here, since we don't know what distance we want to move our motors, we just want to set them to go at a certain speed. Here we set our left to go at 30 and our right to go at also about 30. Two quick things to note. Due to the way that my robot is set up, the left motor and the right motor are going in opposite directions, so in order for me to have them both turn in the same direction, I have to set one to be positive and the other one to be negative. And then another issue is that the left motor kind of just inherently turns a little faster than the right motor. Again, this is something inherent to my setup. So here I have 30 power for the left motor and 33 power for the right motor to kind of compensate for that. You might have different issues where your motors might be mismatched in a different way, but generally in an ideal world, these two numbers would be the same. Now, once we have hit our 6 centimeters, we then want to move away from the wall. So it's very similar to what we saw before. The only difference, there's only really two differences. First, instead of checking to make sure that our distance is greater than 6 centimeters, we will make sure our distance is less than our initial distance to ensure that we have not backed up further than we needed to. And then the other difference here is that we just have the signs flipped on these two values. So now they're going backwards from the way that they were originally going. And then once we have hit our original distance, we need to make sure we explicitly turn off these motors, because this just sets a power, but it doesn't set a duration or a distance that it needs to travel before it turns off. It would go forever if we didn't do anything, if we didn't tell the motors anything else. So we have set motor left, the left motor we set to power 0, and the right motor we set to power 0, and then we are done with our program. Now there are other things you can do with the distance sensor, but this is the main way that you're going to want to use it to make sure that you're getting distances. Technically there's lights on it as well, but if there's anything else that you want to see what you want to do with the distance sensor, you can just look in the knowledge base where it has all of the different functions you can use for it. And that is how you use the distance sensor.